Okay, so this unit that we're doing is called Counting Principles. And you're going to learn two things you've never ever done in math anywhere, called permutations and combinations. That's what we're going to be focusing on in this unit. Okay, so you have two things called combinations and permutations, and you have stuff like that on your formula sheet. So if you can look at your original formula sheet. For this unit, we are going to use these three formulas from your formula sheet. So this section is going to deal with this unit. Okay, so obviously permutation and combination, you can tell which formula is what. Permutation is the P, combo. All right, so I'm going to write down combination. And permutation. Okay, so you have no idea what any of that means, and that's fine. We have it on paper. So here's what this is all about. Okay, I have 4 colored markers here. I need to make a combo picking 2 markers. Can you give me some options? What could I do to pick 2 markers? For instance, the first, I could go blue, yellow. Okay, Gabe, you're tallying this up. You're going to write down on the little corner of your paper. That's one option. Just do a little tally tick mark. Okay, can anybody give me another combo I could do? Pink and orange? Okay, there's 2. Something else I could do. Yellow and orange. I'm at 3. Orange and blue. Gabe, what are we at? 4? Blue and pink. So I'm at 5. And yellow and pink? That's another combo. 6. I think we got them all, right? Okay, so if I told you you could only take 2 markers back to your desk with you, you would have 6 different ways you could do that, right? 6 combos. Okay, so that's what a combination is. All right, now a permutation is different. So a permutation is now I'm going to take things, but I'm going to be placing them in an order. So for me, if I was to do 2 items, I'm allowed to only have 2 items, but a permutation, I could pick up blue, then I could pick up orange. Okay? Or I could have also done orange and then blue. That's different. Okay? In a permutation, that's different. In a combination, that's the same thing. Okay? A combination is just what could you have. Okay? A permutation is now I could have them, but I could pick them up differently. I could pick blue, orange, or I could pick orange, blue. Okay? So that's the difference between them. Okay, so combination, does the order matter? No. An example, picking a committee. Like a student council needs 3 people to run the lunch hour fundraiser. Does it matter what 3 people they pick in an order that they pick? No. Permutation, does order matter? Yes. What about gold, silver, bronze? If you picked people to win a race, would the order matter of where they're finishing? Yeah, now that permutation is ordered. Okay, so this is what it's all about. now let's go to our calculators here. I want to see if you can find your buttons. So what I did was I had 4 markers and I chose 2 markers. So I'm going to show you mine and then you can see if you can find yours. So mine, I have to push the number 4. And then you can see on my calculator I have this NCR. So I go that and then 2. And then equals, and remember we had 6 ways we could have picked markers. Okay? Some of you, is yours like that or did you not find it? Okay. Some of you have a different calculator. Oh no, you have yours right here.
Oh, I do?
Yeah, yours is right there and your P is above it. Anybody not find theirs? Okay, so this is a different style calculator. Anybody who has this one? So I'm going to push 4, and then there's this button called probability, and then there's in the list. So I have to move to the right, enter, and then push 2, and then enter. Okay, so everybody who has this calculator, you have a button called probability where it's under. Anybody not find theirs after those 2 examples? Still didn't find it after that? You got it. Okay, so there's 6 combos. And then can you try typing this in with a P? How many different ways could I pick up 2 markers? So N, and then can you find your P button? Your permutation button? And now there's 12 ways I could have picked up markers, right? Because I could have done blue-orange was 1. Then I could have actually done orange-blue, 2. I could go blue-yellow or yellow-blue. I could do blue-pink or pink-blue. I could go with orange-yellow. I could also go yellow-orange, right? Do you see what I'm doing? Different orderings as well. Okay, then did you notice these formulas have these exclamation marks? That is not English exclamation. That means in math, factorial. So what does 4 factorial mean? So 4 factorial means 4 times 3 times 2 times 1. That's what a factorial means. Can you get me that number in your head without your calculator, actually? 24. Okay, so let's find the shortcut button. So on my calculator, I have an N with an exclamation, so that factorial. So I just go 4 factorial, and then I push equals, and you said it should be 24, and it is. So probability button for some of you, again, it's under there. Jared, do you see yours of that? Anybody not find their N? Jared, where's your Okay, so 7 factorial what does it mean? It means 7 times 6 times 5 times 4 times 3 times 2 times 1. You always stop at 1 is the most you do. And can you use your calculator button? So give me that button. Please don't push all those numbers in. Just give me 7 factorial like that with the button. Equals. Okay, so here's this N and the P are, so this means I'm going to permutate. N is always going to be the total objects available, and R is the number of objects like selected. So for example, if I had a situation like this, 10P3, it's me saying, hey, there's 10 people running a race. How many different ways could I be handing out 3 medals? Gold, silver, and bronze. So it would mean 10 total racers and you're trying to give 3 medals. And you're trying to figure out, how could I give these medals? So like Gabe could get the gold, and then Caden could get silver, and Moses could get bronze, or we could give Caden the gold, and then Lindsay the silver, and Nolan the bronze, right? There's so many different ways to do that. Okay, I'm trying to think of what I want to do today. Let's go skipping the word problems. Okay, let's go to this one question. Simplify 91 factorial divided 89 factorial. Okay, if you tried to type this into your calculator, the calculator would say, no, thank you. You can't do that. Why can't you do that in a calculator? Do you know how big that number is? Can you visualize what is 91 times 90 times 89 times 88 times 87? Can you imagine how big that number is? Your calculator does not have the power capacity to do a number that big. Okay, so what we're going to do is we're going to expand this out. So what is 91 factorial? 91 times 90 times 89 times 88 times, like, right? Do I have to keep doing this? No. It's going to go on and on and on and on, right? And then 89 factorial would be like 89 times 88 times on and on and on and on and on and on, right? Would we be able to do some canceling? Basically, I would say anything and beyond would cancel like that. Okay? I don't want you to write it like this, though. I just did this to show you what was happening. This is what I want you to do. I want you to go 91 times 90 times 89 and beyond. Because 89 factorial is going to include 89 and then the rest. Divided by 89 factorial. Does that make sense? That's the same thing that was happening. Okay, so this is how I actually want you to write it. To say 89 and beyond, 89 and beyond. That's what you're doing. And now, can your calculator handle that? Just 91 times 90. Okay, so let's go flip, 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 flip. Like right almost to 3/4 of the way. I think this is what I'm going to start with. Okay, we are going to do these equations and expressions. Okay, so I have my formula sheet here. So I have 20 objects and I need to choose 4 of them. So I'm going to do this. What is n factorial? 20 factorial. Divided by r factorial, which is 4 factorial. What is n minus r? What is that going to make us? If we do the n minus the r, can we just go 16 factorial? Divided by a 17 and a 19. If you guys would like to keep your brain in line, you can always write that over 1 so that we can understand eventually this times flip stuff, right? Okay. When I look at this, I'm going to expand some factorials. Which one should I start expanding? What would make the most sense to expand? I'll give you multiple choice. It's either the 20 factorial or the 16 factorial. Which one would you expand? 20. Yep, you always pick the larger one. So here we go. 20 times 19 times 18. How do I know when to stop? When it hits to the 16. Okay, so I did 2 things at once here. I expanded the 20. I stopped when I hit the 16, and I also times flipped. So I did 2 things there. Okay, so now guess what's going to happen? This 16 and beyond and that 16 and beyond are going to cancel. You know what else you could do? 17 and a 17. And you could also do a 19 and a 19. Okay, so we have a 20 times an 18 left on the top. You're not allowed to use a calculator. You can do it. You ready? On the bottom, this is a 4 factorial. Can we change that? What do you want to do for 4 factorial? 4 times 3 times 2 times 1. Okay, is there anything you can reduce? What do you want to do here? What did you say? The 20 with a 4? Okay, let's do the 20 and the 4. What are we reducing by? 4. So this would be gone, and this could become a 5. Okay, so that's gone. I'm actually just going to cross the 1 out too. Okay, that's what I have now. What else could you do? I can reduce this. What is 3 times 2? 6. So I could reduce by 6. Okay, so if I reduce by 6, this would be gone. And reduce by 6, this would be a 3. So the final answer is 15. Okay, this one, it's already something for me. which factorial do I expand? You have 2 factorials here. This factorial or this factorial. Which one should you expand? Which one is bigger? The top one is bigger. N plus 3 is bigger than n. Okay, if you go down 1, we're always going down 1. What's the next thing if we go down 1 from that? N plus 2, down, n plus 1, down is just an n, and then I, and beyond. Stop. Okay, so I expanded it down, 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 down until I was matching with another factorial, right? That's my process. Okay, so n factorial, n beyond, like, right, there's more stuff after it, but it's all going to cancel all that, n beyond. Then this factor is also going to cancel. And I'm left with this, but the word of the question says I have to simplify. So is this simplified? No, this is factored. How do I simplify this? I have to multiply it, right? Because if I say what's 4 times 5, you would say to me 20. See, that's multiplying it. So I'd have to multiply this. A common mistake, you guys are so used to solving, factoring and solving, and then people try to solve this. This is not solving. You don't have an equal 0 or anything like that. So you're not solving for anything. You're just getting an expression. Okay, here we go. There's 2 factorials again. Which one do you want to start with the expansion of? The top. The top is bigger. So n plus 2 is bigger. N plus 2. Okay, one lower. N plus 1. Lower. N and beyond. Okay, so this factorial would cancel that factorial, like everything else after it would just be getting canceled. Okay, which one is bigger? Is this factorial bigger or this one? The bottom is bigger. So I'm going to leave the top. Okay, so n plus 1 is bigger. So go down from n plus 1. N. Go down from n. N minus 1. And now I can stop and say it would just keep going. Okay, go ahead, write me this answer, simplified algebra here. Let's see if you can get it right. What does your expression look like? Simplify it. Okay, ready for my answer? Did you all write 1 over? Yeah. Good job. Because the top canceled. So don't just write something, write 1 over something. Did you get it? Remember last year we talked quite a bit about that. If the top canceled, don't just write the answer, you have to write 1 over, right? Okay, two more like this. So here's a factorial and here's a factorial. Which one of them is bigger? That's kind of where I always just start. Bigger. Okay, so give me n plus 2. Lower it. N plus 1. Lower it. N. Another one, n minus 1. Okay, stopped, right? Why did I stop? Because I matched the other factorial. Expand, larger, 1 until you match. Okay, now can we go cancel, cancel? Divide both sides by n plus 1. That's okay with you? What else could we do? Cancel, cancel. All right, now we're going to be into your grade 11 brain. See if you know what to do. What's your instinct telling you right now? Was it that instinct? Okay, so that's your first instinct. What's your next move? Equals 0, right? Always thinking like that, equals 0. And now you can factor. Remember how I used to say that factoring unit was like 90% of grade 12? You got to master it.
I thought we weren't solving it.
This is a solve though. Right? There's an equal sign. Do you see a difference? What was this? There's no equals anything. There's no solving. So this is just you simplifying an expression. And here, now we're solving for an equation. Sorry, the directions were at the top there. I guess I didn't go through them. Okay. We need to talk about this answer because some of it works and some of it doesn't. If n was 5, this would be a 7 factorial. Is that an okay existence? Yeah. 5 minus 1 would put this at a 4 factorial. Can we 4 factorial something? Yes. If n was -7, -7 plus 2 is -5. Can you do such thing as a -5 factorial? No. So you have to eliminate that. What do we have to stop at with factorials? What's the lowest factorial we would do? 1. You can't factorial, right? As soon as you factorial, we stopped at a 1. So I can't. It's not because this is -7, because if I had this, if I had had this factorial, would -7 be okay now? Yes, -7 would have been okay here. Okay, it's not that the solution was negative, it's because when I put the solution into the factorial, it was a negative factorial. That's the bad. Okay, good? Yeah? It's not that the n was negative, that wasn't the bad thing. It's just that when I plugged it in, it was making a negative factorial. Not good. Okay, I need you to give me a formula. So you're going to look at your formula sheet, and then you're going to figure out how to write this as a formula. Formula. So look on your sheet, replace it with a formula. How did you do? Did you follow the formula? Did you put this exclamation point factorial out of the bracket there? Because if somebody did this, that's wrong. This is wrong. Okay, that's not what you're doing. Okay, expand the larger factorial. So I'm going to look at either this one or this one. Which one am I picking to be larger? N? Okay, go ahead. So N. Go down. Go down. And beyond. Does anybody know what 2 factorial is in your brain? 2. Because what's 2 times 1? Okay, so it's not that I forgot to write the sign, I just evaluated it. Okay, that cancels. Okay, how are we looking so far? Okay, what are your algebra instincts telling you you should do? I'm going to want to times those out. I'm also going to want to do something else. I'm going to want to times both sides by 2. Do you see that instinct? Okay, so I'm going to do 2 of those things at the same time, if that's okay with you. So I FOILed this part out, and then I times both sides by 2. Now, grade 11, what are you going to do? Zero it. Is that what you're going to do? Zero it. Factor it. Okay, talk about your answer. What does this mean? Can you have 10 objects and choose 2 of them? Yes. Can you have negative 9 objects and choose 2 of them? No. Can't do a negative 9 object.